All right, today we're going to be talking about rational functions that have a hole in the graph. Okay, so we're going to be talking about what a hole is, where it comes from, what it looks like. Okay, so we have this rational function here and doing an easy one. Okay, but before we get started, what we can notice right off the bat is that the factors in the numerator and the factors in the denominator, I've got 2 and 2. Okay, but notice I have this same factor showing up here, x minus 2 and x minus 2. Okay, and we know that if we take that, we can divide it out, right? X minus 2 divided by x minus 2 is 1. So we're left with x plus 4 over x plus 3. Now, that doesn't mean that it's gone, okay? Because basically what's happening here is if I had done my original information without doing that, I would have had an x-intercept at 2, 0 from the numerator, and in the denominator I also would have had an asymptote at 2, a vertical asymptote. So when we would go to graph it, we'd put that x-intercept and we'd have an x-intercept on an asymptote, and that is not possible. So since we can't have both, what we do is we remove it and we deal with this one, and we actually create what's called a hole in the graph, okay? Because we can't technically put in positive 2. So I'm going to have a hole in the graph
You've
at
got
positive 2.
mail.
Okay? So what's going to happen is, and we'll figure out how to do this in just a minute, but we're going to use this equation right here to find all of my information. So I do have an x-intercept at negative 4, 0. My vertical asymptote is at x equals negative 3. Again, my horizontal asymptote, power on top and the bottom, is the same. So we use the coefficients. So our horizontal is at y equals 1. And then our y-intercept, when we plug in 0, we get positive 4/3. Okay? Now, what we're going to do is, if we had taken 2, and this is going back to basically what we're talking about with the hole, if we had used our regular original equation, if I had used this one right here, and I plug in f at 2, I would have ended up with 6 times 0 over 5 times 0, and I would have gotten 0 over 0. Okay? 0 over 0 is a special form. It actually has a special name. We call it indeterminate form. Okay? Because you cannot take 0 and divide it by 0 because it's indeterminate. And what that means is that we can't tell what it is because it's technically 3 possibilities. 1, anytime you have 0 divided by any number, that's 0. So this could be 0. But we also know we're not allowed to divide by 0, so technically it should be undefined. As well as any number divided by itself is supposed to be 1. So I have 3 possibilities there. It could be 1, it could be 0, or it could be undefined. And since we don't know which one of it is, we say that it is indeterminate. We cannot determine the value. But what it does tell me is that I have this factor here in the top and the bottom that is causing that 0. And it has to be the same factor because when I plug in 2, 2 minus 2 is 0. 2 minus 2 is 0. Now, in this one, in the blue one, if I plug in f at 2, I'm going to get 6 over 5. And I don't get that 0 over 0. Now, the only difference between this one here and this one here is this x minus 2 in the top and the bottom. Matter of fact, if you plugged both of these into your calculator, the one missing the x minus 2 on top and the bottom and the one with it, you'd freak out because it would literally graph the exact same thing. You would think there was something wrong because it would graph the first one and the second one would graph right on top of it. You wouldn't even see it because they are identical except for the fact of this hole. Okay? So we can use this second one without it to actually find our hole. And that's what we just did. When I plug 2 into with the factors, I get 0 or 0. But when I plug in 2 without the factors, I get 6 over 5. And that's where my hole is. It's at 2, 6 over 5. And we're going to graph that hole when we graph our information. Okay? So holes occur when I have common factors in the numerator and the denominator. So let's graph all of our rational function information. So our vertical asymptote is at -3. Our horizontal one is at 1. I have my x-intercept at -4. My y-intercept is 0, 4/3, which is here. And now I have to graph this hole, and we're going to graph it as an open circle. So we're going to come over here, 1, 2, 4/3 is like right here, and we're going to graph a little open circle right there where it would have been. Okay? Now we're not putting it on the x-axis because this was never going to be an x-intercept. We're graphing it at 2 6/5. Now we can graph the rest of our curve. Okay? So again, we have one vertical asymptote graphing two pieces. On the left side, I know it's going to go like this because I have this x-intercept down here. So it's going to cross the x-axis and it's going to follow the horizontal out. And on the right side, that hole is actually going to help me graph my function. Because now I have 2 points. I have my y-intercept and I have where this hole is. So they have to connect like this. And it's going to keep going this way. And this one's going to go up the vertical asymptote. So at the beginning of the year, we talked about a function, what makes a function continuous versus discontinuous. And we talked about how to be continuous, you have to be able to draw it from beginning to end without picking up your pencil. So for this one, I'm going along, I have this, it goes down here, and then you have to pick up my pencil and then come back here and draw the rest of it. But here, when I get to this hole, I'm going to jump over it and go to the other side. So when we talk about the domain of these functions, right, our domain of this function is basically going to be everything, all real numbers, except where my vertical asymptotes are or where my holes are. Okay, so a vertical asymptote and a hole are excluded from my domain. So if I said, hey, tell me what is the domain of this function? Basically, it is all real numbers except x cannot equal -3 and x cannot equal 2. And that is the domain of my function. And the reason that it can't be -3 is because I have a vertical asymptote there. And the reason it can't be 2 is because I have a hole in the graph there. But all of my other ones, all my other x values are absolutely in the domain. Okay? So let's look at another example of a hole. Okay? Here we go. So the first thing we do is we look, do we have any common factors? Well, yes, we've got a common factor right here of x minus 6. So I have a hole in this graph. Okay? And my hole is going to be at 6 because that's what I'm going to remove, the solution. So the real function I'm going to be graphing is this one without those two factors. And that's where I'm going to get all of my information. But I had to write this down here, this hole, so that I know where my hole is. Okay? And now we just find the rest of our information like normal. So we have an x-intercept at -5, 0, a vertical asymptote at 3, and another one at 1. My horizontal asymptote, since the bottom is bigger, is automatically at 0. Then we plug in our y-intercept, and we get 0 plus 5, which is 5, over negative 3 times negative 1, which is 3. So positive 5/3. So the last thing we have to do is now find where our hole is. And we plug in 6 into our function. So 6 plus 5 on top, 6 minus 3 times 6 minus 1. So again, we're plugging it into the one that we crossed out the x minus 6 in, okay? Because if we plugged it into this one with the x minus 6, we're going to get 0 over 0. So we plug it in here, we get 11 on the top, and we get 15 on the bottom. So our hole is at 6, 11 over 15. Okay? So now we're going to graph all of our information, just like before. So we have a vertical here at 3, another vertical at 1. Our horizontal is at 0. Our x-intercept at negative 5 right here. Our y-intercept at 0, 5/3, which is right there. And then our hole, which is at positive 6, 11/5, which is right here. Okay, that's all of our information that we have. Now, we have 3 pieces to graph. So here we go. Well, let's start on the left side. I do have 2 points, okay? And since I know that these 2 points have to connect, and it crosses the x-axis here, it's going to look like this. So the left side's really easy because I have the y-intercept and the x-intercept there. On the right side, I also know that side real easy because either, since there's no x-intercepts, it's either going to be all above the horizontal asymptote or all below it. But since I have that hole sitting right there, I know automatically it's up here. So using that hole to graph my right side helps me a lot. That just leaves this middle part, and the only way to do this middle part is I'm going to have to plug in a value. So I'm going to have to look and see what's happening at x equals 2. So when I plug in 2, I get positive on top. I get negative 1, positive 1. So a positive divided by a negative is negative. So in between 1 and 3, I'm on the negative side. And again, since there's no x-intercept there, I can't cross. So that means it has to come up this side and then turn around and go back down. So when we have a hole in the graph, basically the only thing that we have to worry about doing is dividing out our common factors and then using our new equation without those common factors, plug in the solution that we got rid of to find the hole and where it is going to be on our graph. And then that hole again will tell us a lot about our function. It's as useful as our x and our y intercepts when graphing these.